Om Sri Sai Ram. Welcome to the computer science class video part for your pointers. So we are now in the last part of the video of pointers as far as our syllabus is concerned. So you have learned so many interesting things in the pointers, that how the pointers is helpful for manipulating the variables and arrays as well as the structures, and while passing the arguments to the functions, and especially for manipulating the arrays. So we get a lot of flexibility, and it resolves so much complexity when you work with the pointers. So we have seen how to create the integer pointers, how to create float pointers, how to create character pointers, and even though we have created how to create a pointers to the arrays, and the important part we have seen, a very interesting part is array of pointers, that is array of addresses. And then we have seen how we can create a pointer to a class object also. That was very interesting part. So today's topic is this pointer and the memory allocation. So we are going to see such a pointer today that we don't need to create. Compiler already creates for us, and this is completely based on the concept of the classes and objects. So we are going to learn today this pointer, then memory layout of C++ programs. Here we are going to study how to allocate the memory manually, that we call it as the dynamic memory allocation. So there are two types of memory allocations, static memory allocation and dynamic memory allocation. That is also a very interesting point to learn. So once you learn this, then you will get a complete idea that how C++ program executes in memory. So let's begin with this pointer. What is meant by this pointer? Before going to the technical definition, let's understand the meaning of this, why we call it as this pointer. This has a real world meaning. Suppose I say this is a pen, this. So pen is an object. I am saying this is a pen, means I am referring to this object. So as I am using the term object, so here this pointer also refers to an object. But which object? It refers to the current object. Which current object? That we will see point by point. Every object of a class maintains a hidden pointer to itself. When we create an object of a class, it maintains a hidden pointer itself, because when we create an object gets allocated a memory space in the memory, and as we know, every memory cell is having the address. So a object is having an address. So the object of a class maintains a pointer within itself, and that pointer holds the address of a class, and the name of this pointer is this. We call it as this pointer. What is the use of this pointer? The use of this pointer is while calling the function, member function of a class. We see that whenever we call a member function with a certain object, that member function displays the values related to that object itself. That we are going to see with the example. So particularly, actually this is a reserved word and is the name of pointer to an object of a class. This is a reserved word, means it is a keyword. That means you cannot use this word this, this, for naming a variable, for naming a function, for naming an array, structure or a class. So you cannot use to define any other name. So this is a keyword in C++. So when an object is created, the compiler creates this pointer which keeps address of the object. Compiler creates this object. We don't need to write any code to create this object. And this object, this pointer, is having access to all the members of the class. What are the members of a class? The data members and the member functions. How do we access the data member and member functions? We access the data members and member functions with the help of an object. If you once again, means for the sake of some students, I would like to write here that suppose there is a class test, something there in the class. So in main we create a object, say test T, and by using the T we access the members of a class. Just like a object is having access to every member of a class, here suppose there is int x in public section, so we can access int x here. As object is having access to the member of a class, generally we access the public members by using the object. We cannot access the private members outside the class. So the same thing we can do with this pointer. So this pointer becomes implicit argument. Implicit argument of the function when object calls a member function of the class. What is meant by implicit argument? If you remember, when we have studied constructors and destructors, there we have explained this term very well, implicit and explicit, these two terms. Implicit means what? That you are not writing a code for doing some task. Compiler is writing a code for doing a task. So here also we are not creating this pointer, but compiler is creating this pointer to us. So when you call a function, a member function of a class, then one argument is internally passed to a function, that we call it as an implicit argument. And what is that argument? That argument is address of the object. Let us see with this example. Consider this is a class C name, and in this class there is a function display which is printing a simple statement, that is hello. And here in main I have created an object of class C name obj, and I am invoking a function display obj.display, and it is printing the output as hello. So what happened here? How does a display knows that what to print? So here actually we are not printing anything which is object specific. If you create another object also here, say I am creating another object, suppose here obj2, and if I call obj2.display, then also what will happen? It will print hello only, because we are not printing any object specific data. What I mean object specific data? We will see here. Whenever you create a class, compiler allocates memory for the class itself, and when you create an object of a class, say for example here I am creating one class, I am creating a class, say student. In a student class I will just create the variables for storing the basic information of a student. A basic information means just the ID of a student and name of a student. I am keeping this example very simple because we want to understand the technique of this pointer. So here for ID I am declaring one data member as ID, and for name I am simply declaring one character variable name. So here I am just declaring one character variable. I am not declaring character array here. I will just input the one character name here, and I will write a constructor, as we know that constructor must be defined in public section. So constructor I am going to write here. Constructor name should be same name as that of a class. So I am going to add a parameterized constructor here. So I have to declare a parameter here, int x and char say nm, And what I am going to do, I am going to assign the value of x to id and I am going to assign the value of nm to name, and this constructor is over here. Now I want to write a function which displays these details. So one function I will write, void display, and nothing will be here. So what I am going to display here, cout is id is equal to id and then another name, cout name is equal to name. This is my class definition, very simple. Let us understand once again. I have created one integer variable id to store the id of a student, a character variable name to store the name, single character name of a student, a constructor I am defining to initialize these variables. So parameterized constructor I have added here, which takes one integer parameter and one character parameter, and the initialization code I have written here. I have written one display function which displays the id and name of a student. So to implement this class we have to write main function. I am going to write a main function here. I am writing here void main. So what we have to do, we have to create an object of a class. So I am creating here student s1. As a parameterized constructor is here, I have to pass a parameter values for x and nm. So the first parameter value I will pass here 101, and the second parameter value is a character I am passing here a. So that means for student s1 the id will be 101 and the name will be a. In the same way I am creating another object of a class student s2, and here I am passing different values for id 102 and for name b. And then when I call s1 dot display, what output I will get? I will get the id as 10 and name as a. And when I write s2 dot display, what I will get? I will get id as 102 and name as b. So here output will be 101 and a, and here output will be 102 and b. Why? Because for object s1 the values of id and name are 101 and a respectively, and for object s2 the values of id and name are 102 and b respectively. Because what happens in memory, so let us understand here what happens in memory. Keep this program in mind. For a student object, this is a student class. This is a student class which is having variables id and name and function. One is the constructor and student constructor and the display function. So this much is there in the memory for this student class. So for the student class, what I have done? First of all, I have created one object s1. So what happens when you create object s1? It creates the variables ID and name for S1, and when you create S2, as we are creating object of a same class, so we are getting another copy of ID and name for S2. This happens. So what happens? Compiler allocates a space for object S1 and space for object S2, and both will be having their own data members, copies of data members, ID and name, ID and name. Now what happens when you call a function display or when you call the constructor student, right? So compiler checks which object is calling the function. When you call the function with S1, what is happening? The values of S1, S1's ID and name gets passed to the student. Who carries this value? Actually, we are not passing any value. S1 is having this pointer, this object is having the address. So x0, a, b, d, e, like that, and this is also having some address, a, b, c, d, e, something address it is having. So this address is carried by this pointer to this one, and this function accesses these memory locations. So this one, what happens then? The whatever values you are passing to the student, that will be allocated to the ID and name of S1. In the same case, when you call the constructor with S2, it allocates the ID and name values passed by the S2 to the student. So both the objects are invoking the same set of instructions. We don't need to create a different functions for each object because function is same. The task we are performing same, but the task is being performed on different set of data values. That's why a different set of data values gets created for S1 and S2. Then, but how does a function knows? Function knows because with the help of this pointer, it gets the address of that particular object. And when you call the display function, in display function there are only instructions. So what does those instructions do? When you call the display with S1, then displays this pointer, receives the address of S1, and then with the help of pointer we can access the memory location of the object. So with the help of this pointer, this display function accesses these memory locations and displays the contents of ID and name of S1. And when you call the display function with S2, that time this pointer receives the address of S2, and then this pointer accesses the memory location of S2's ID and name and displays the contents of ID and name. Got it? So let's understand now actual use of this pointer, how to access the memory location using this. So m is equal to 10. Consider here in memory we have created one variable m. The name of a memory is having name as well as some address. So this 10 is allocated here. So one easiest way of accessing the memory is with the name of variable or name of memory location, that is m. The use of this is like this. By using this and the arrow operator we can access this m. This name of the pointer, then arrow operator m and 10. In this way also we can access the m. So this is also accessing this m, this is also accessing this m. Or if you remember the last class, last part of the video, in that alternatively we can use the dereferencing operator. Instead of using the arrow operator, we can use the dereferencing operator and the period operator. This way also we can access the m. These are the three ways. A question may be at this point arising in your mind, if we can access this memory with the simple technique that is m, then why do we need to use these complex operators here? That we will see. Now this is a simple program. It is the same program which I have created. I have created a class named mobile. I have given the name mobile. There is no specific meaning, but as all of you likes the mobile, that's why I have given the class name as mobile. Otherwise, mobile do not have any concern with the class code. So here I have created one variable m and assigned 10 to it. And then in a display function, what I am going to do is, I am just going to print the contents of m by using the variable name m, by using the pointer this way with the arrow operator, and by using the dereferencing operator and printing. So if we execute the code, we will get the output as 10, 10, 10. So for display, I have called the display function with the object of the mobile class. In the same way, as we can allocate the data to the variable by using the variable name, we can use the this pointer for allocating the data also by using this statement. This arrow operator m is equal to 10, or we can allocate by using this statement also. Dereferencing operator, this parenthesis is important. Why this is important? We have discussed in the last part, because this period operator is having the higher precedence over the star operator, sorry, this parenthesis operator. That's why we wanted to have this parenthesis here. So one more question may be arising in your mind. Suppose we assign here value 20 rather than 10, 20. So what it will output? So just you think, what will be the output of a program, whether it will output 10 or 20. So there is nothing new in this, just the writing of code, the way of writing the code is different. Otherwise it is as same as you have allocated first 10 to the memory, this is m, 10, and then again you are reassigning the value, that is 20. So what will happen here? The earlier value will be erased and the new value will be written. So this is as simple as this one. So you know, the memory returns the recently allocated value. So it will allocate 20. So it will print 20. There is nothing new in this. But again, your question is answered, that why we are going to use this pointer. So the answer is in the next slide. Here, this program is same as the previous program. Nothing new. Display function main. Only new thing I have added is the get data function, which is the parameterized function. So in the get data function, I am asking for one parameter, integer parameter m. So here you can notice one thing, that the name of the variable and the name of the parameter is same, and as this function is within the class, so this function is having the access to this m as well as to this m, right? So when you call the function get data with the object and pass the value 20, then it is expected that this 20 will be allocated to m and this 20 will be allocated to m. Got it? But what happens? Here scope of the variables are different. This m belongs to the class. So class memory is different. Class memory is different. This m is created in class, and this m is created in this function scope. Which one? Get data. So the scope of both the m is different. Okay. But this get data is having access to both the m. So when you call this get data function, so here compiler is getting confused, that which is this m and which is this m, whether this m is this one or this one is this one. It is getting confused, whether you want to allocate a 20 to here or what is the problem, right? So that's why when you execute a code, right, we are expecting that we will get the output as 20, 20, 20, but here we are getting the output something else. What is this something else? As compiler is confused that which value to print, basically it is not allocating a value itself. That's why what is happening? It is printing some garbage value. So here the use of our this pointer is making a sense. This pointer resolves this conflict. Whenever the parameter name and the variable name is same, that time we can use a this pointer here. So this will be replaced with this statement, this arrow operator. So here we are clearly indicating that this m belongs to the current object, say obj. This m belongs to the current object obj, and this m is this parameter name. Or you can use this statement, both statement meaning the same, but this is preferred over this statement. So when you write the code like this and then execute a program, then you will get the output as 20 20 20, because then here the right kind of allocation is happening. So this is the main use of this pointer. Now one more example. What is this one more example? We want to check whether this pointer is actually carrying the address of current object or not. Here same function we have taken, but only what we are going to do, we are printing the address carried by this pointer. And we have created the object of this class time t1 and t2, two objects we have created, and we are printing the address of t1 in main. We can print with the help of address of operator, and we are calling the function display address. What display address is doing? Display address is printing the contents of this, right? And if you see the output of these two statements here, the address of the object t1 is 0x69FEEF, and the address printed by this is also 0x69FEEF. That means it is very much clear that this is carrying the address of t1, that is the current object. But you may again want to recheck what happens when we call the function with the another object. That also we have demonstrated here. We are printing the address of t2 also with the help of ampersand operator. So what is the address of t2? 0x69FEEE. And we are again calling the function display address but with t2. So this time the contents of this is the address of t2. You can see here the address printed by this also 0x69FEEE. So here it is a complete proof that this pointer carries the object of current object. Current object means the object which is calling this function at that moment. This pointer carries the object of that current object. So hope you have understood this thing very well. This pointer, what is this pointer, and is very interesting thing. So let's come to our new topic, that is memory layout. Here we are going to see the dynamic memory allocation, which is very interesting point. So when we are writing the C++ programs, we must understand the memory layout for the C++ programs. So what happens in a computer, when you create a C++ program, computer allocates a block of memory to the whole program. So the size of this block of memory differs from the memory model which is being used. So this is a different segments of the memories which is being allocated for a C++ program. So first part that you are going to see here is the code part or the text part. So whatever these codes or instructions you are writing in a C++ program, this area is allocated to that code. The second part is generally where is the global variables or the static variables of the program resides here. And this one part is the stack, right, where generally the pointers or the, when we call frequent functions and the values written by the functions or the addresses written by the functions, we call various functions. So that is being created in a stack, and this is the free store heap area that is actually the point of discussion of our today's topic here. So this heap area is where we are going to allocate a memory with the help of new and delete operator. What is this new and delete operator that we are going to see? This space will be allocated during the execution of a program. We call it as a runtime. So here, with the help of the new operator, we can create the dynamic memory. So the syntax for the new operator is new data type. So here we are going to write a code with this syntax that I am going to create a new and data type int. So what's happening in the memory? I am drawing a memory picture here, say heap. This is our heap memory area. So on the heap area, I have created one memory dynamically, which is of int. And as this is an integer, it may be allocated 4 bytes or 2 bytes. That depends on the processor and the compiler we are going to use. So we don't have to worry about that, whether it is allocated 2 or 4 bytes here. So int is created, and as we know that a memory location is having an address 500. So we just created with this code 500 memory location over here, but we don't have any mechanism to access this one. How to access this memory content we have created? So here what we are going to do is we are going to create one pointer star p. So where this pointer will be created? This pointer will be created on a stack area. So this code may be in a function. So the function may be having other local variables, and then apart from that we have created one p over here pointer, and it is also having some address. So that we don't need to do it. And as this new returns the address, so if we write the code like this, if p is equal to new int, what is going to happen is the memory created over here, it will return the address, new operator will return the address, and it will be stored in a p. So actually this complete line of code will be like this: p is equal to new int. This won't be like that. So p is equal to new int. So p is having access to that memory location. So what will be the contents over here? We have the dereferencing operator. By using the dereferencing operator with the p, we can assign contents to the newly created memory. So here 10 will be allocated this way. So then next time when you create one more memory location here with the p itself, p is equal to new int here. So a more memory location will be created over here. So what is going to happen? Say it is having the address 700, and this p is no longer will be allocated, no longer will be pointing to this memory location. It will be dereferenced from here, and it will be pointing to this memory location here. And with this one we can store another contents to this memory location. So 20 will be stored here. So what will happen with this memory which is not being used over here, but still the memory is over there? So it will add a garbage value in the computer memory. It will be a waste of space. So that's why before creating the new memory, what you have to do, with the help of the delete operator, you have to delete this p over here. You have to delete this p over here. Then this memory will be deleted. And suppose you are deleting p here, over here. If you are deleting p over here, what is going to happen? The p from the stack will be removed, but this memory will still be there. So this also you have to delete. So actually the delete P is not going to be delete the P over here, it is going to delete the memory which is referenced by the P. So it will delete this memory over here. P will remain as it is over there on the stack. So when the P will be deleted, when your program will be terminated, that time P will be deleted. So let's see the use of this operator with the other example. So if you create the float memory in the memory with the help of the new operator, it will allocate that much number of bytes for the float. And we can also create an array with the help of the new operator. So if you are creating array, then 5 blocks of memory will be allocated for the array over here. And P points to the 5 different locations of int type 0, 1, 2, 3, 4 and 5. Basically the P will be receiving the base address, that is the address of the first memory location over here. Let's see this example program. Here we have created an array of 5 integers, and with the help of the pointer we are assigning the values at each individual memory location. So 10 will be stored at the 0th location, 20 will be at first, 30 will be stored at second, then 40 will be stored at third, and 50 will be stored at fourth memory location. And we can print with the help of P of I. So if you print this one, then you will get the contents of 10, 20, 30 and 40. Now our main objective today is memory allocation for the objects, class objects. That is our main. So the memory allocation for our primitive data types or memory allocation for the objects, it is almost of the same thing, only there will be the difference in the size. So the memory for objects is allocated when they are declared, not when the class is specified. When we write a class, that time the memory will not be allocated. When you create an object of a class, that time the memory will be allocated on the heap. So actually the member functions are created and placed in the memory space only when they are defined as part of the class specification. So when you write a class definition, that time the memory will be allocated to only functions. So since all the objects belonging to that class use the same member functions, we have seen while discussing this pointer, we have seen that all the objects accessing the same set of member functions. So no separate space is allocated for member functions when the objects are created, that we have discussed. So only space for member variables is allocated separately for each object, and separate memory locations for the objects are essential because the member variables will hold different data values for different objects. This we already have seen while discussing this pointer. So let's see how to allocate the memory dynamically for the class object. Here there is a class test and the constructor, and here we are creating a pointer to the class. So pointer to the class we are creating test star p test, and to the pointer what we are going to do here, by with the help of new operator we are going to create an object in the memory. So what is happening, the object is going to be created in the memory and its address will be written to the class pointer. It will hold the address of that object. But here we are not giving any name to the object. The way we have created the integer memory, integer data, or we have reserved the memory for the integer value in the previous slide, here we are creating the memory for the object itself. So the address of that object will be written to this class pointer. So with the help of delete, if you delete IPTR, it will free the memory. If you want to free the memory allocated to the array, then you can use this syntax: delete, then square brackets and dptr. This way you can delete the dynamically allocated memory on the heap. And if you want to delete the memory allocated to a structure of a class, then you can delete like this: delete and the name of the structure or the class. So this is one example which where we have created a class box and we have written one constructor over here as well as the destructor. So there is nothing special written here, only I have added the statement constructor called and destructor called, so that we will come to know whenever the constructor and destructor will be invoked, and it is preceded with the tilde operator. So in the main we are going to create a pointer of objects of class box. So that's why box star my box array. We are going to create a box array, and we are creating an array of objects which is having size 4. So 4 objects we are going to create. So we know that what happens whenever an object is created, it invokes a constructor. As we are creating 4 objects here in the array, a constructor will be invoked 4 times. You can see here constructor called is displayed 4 times because constructor is called 4 times. And as you are deleting the my box array, means all the 4 objects we are going to delete here, so it will call the destructor. We know to destroy the memory occupied by an object, a destructor will be invoked. So here when you call this statement, when this statement is executed, 4 objects we are going to destroy it, so that's why 4 times the destructor will be invoked over here. So this way the memory will be freed with the help of the delete operator. So let's understand the differences between static memory allocation and dynamic memory allocation. This is very important point from exam point of view. Many a times this question is asked. In static allocation of memory, memory is allocated before execution of the program begins, that is at the time of compilation. In dynamic, during the execution of the program, memory is allocated. So we don't know that how much memory is going to be allocated. Then no memory allocation or deallocation actions are performed during execution. Here memory bindings are established and destroyed during the execution of a program. So variables remain permanently allocated on the stack, that is static allocation. We are allocated only when program unit is active. So if your program is not under execution, then memory will not be available over there. And this is implemented using stacks and heaps. It is implemented using data segments, the dynamic memory allocation. So these are the differences between static memory allocation and dynamic memory allocation. So here we are concluding our main chapter, that is the pointer, which is mainly focused on the concept of memory. Hope all of you have understood the concepts of memory very well. All of you understood the use of pointers with the different types of variables, classes, structures, functions, and today's important point, the hidden pointer we have discussed, that is the this pointer, and how we can allocate the memory and delocate the memory dynamically, that is during execution of the program. So hope all of you have understood and happy with these videos. So you can visit the channel for more videos. Thank you. Sai Ram.